All right, so let's continue with 1.5. I had to pause. I didn't want to interrupt. So log functions. So this is still 1.5. Logarithmic functions. So we talk about log functions as inverses of exponential functions in beginning, in intermediate, and in college algebra. So just a quick review: exponential functions versus log functions. The inverse of b to the x is log base b of x. And the base is going to be greater than 0, different from 1. Same thing here. Base is greater than 0, different from 1. Domain of exponential is negative infinity to infinity, and range is 0 to infinity. Domain is 0 to infinity for logs, and range is negative infinity to infinity. Okay, so we went over this, and actually I have a handout on these in under handouts on D2L. And to go from exponential to log, if we have log base b of x equals y, remember the base, so b to the exponent, meaning that y is log, so y is also an exponent. This is the same as, it's the same as b to the y equals x. So we can switch from exponential to log and vice versa using this rule. We did all this in intermediate and beginning algebra. Also, I want to review with you some of the log properties that you might need. So you have log base b of b to the x equals x. They cancel out. If you have b log base b of x equals x, this is true only if x is greater than 0, because you can't do log of negative. Be careful, okay? So when we do, for instance, when we do log of 10 to the x, remember when there's no base, that's common log, the base is 10, so they cancel out and you get x. And when we do 10 log base 10 of x, that's x only if x is greater than 0. If x is not greater than 0, that's undefined. If we do ln of e to the x, that's also x. But if we do e to the ln of x, remember ln is natural log, its base is e, that cancel out only if x is greater than 0. So for instance, if I have e to the ln of 2, that's 2. But if I have e of ln of negative 2, that's undefined. And you can check that in your calculator. All right, then we have the log of the product rule. Log of xy equals log of x plus log of y, base b, of course. And quotient rule, log base b of x over y is log base b of x minus log base b of y. And if you have an exponent, log base b of x to the r is r times log base b of x, as long as x is greater than 0. If not, you need absolute value. And log base b of x, you can do the change of base formula. It's ln of x over ln of the base, or log base 10 of x over log base 10 of the base. Nowadays, your calculators will do anything. Like before, for this example, before, if we want to do, say, log base 3 of 5, we would have to do ln of 5 over ln of 3, because your calculator only had ln or log base 10. So you do ln of 5 divided by ln of 3, and that would give you the answer. Now, with the advanced calculators that we have, if you go to math and then up, there is a log base key, which is right here. Log base, you click on that, and then you can do log base 3 of 5, and it gives you the answer. Fortunately or unfortunately, I don't know, but that's the case. Okay. So if we want to evaluate, just to practice those rules, log base 5 of 1 over 125, we can write this as log base 5 of 5 to the negative 3. 5 to the negative 3 is 1 over 5 cubed, which is 1 over 125, which we get the negative 3. And if we have, say, ln of 1 over e squared, using the quotient rule, it's ln of 1 minus ln of e squared. Ln of 1 is 0, and that's canceling out, so it's negative 2. Or you could write it out as ln of e negative 2, which is negative 2. All right. How do we expand as much as possible? I don't want to spend too much time on this, but I'm just trying to brush up on the algebra that you need. Okay, so using the quotient rule, this will be ln of the top minus ln of the bottom. And then using the product rule, it's ln of x cubed plus ln of y squared minus ln of u5. Normally it would be a plus because this minus goes through all of them, so it's going to be minus ln of z7. And then the exponent goes up front, the power rule. Assuming y is positive, if not, we put absolute value, 5 ln of u minus 7 ln of z. Okay. Also, let's review solving log and exponential equations. For example, how do we solve part A, ln of x squared minus 1 equals 3? Well, since the base here is ln, we e both sides. E to the ln of x squared minus 1 equals e cubed. Because e exponential functions are 1 to 1, we can do that. X squared minus 1 is e cubed, x squared is e cubed plus 1. So x is plus or minus square root of e cubed plus 1. This would be the answer unless they need decimal. Okay, part B, e to the 2x minus 3e to the x plus 2 equals 0. This can be factored into e to the x minus 2 and then minus 1. So e to the x equals 1, e to the x equals 2. Since the base is e, we ln both sides. So x equals ln of 1, which is 0, and x equals ln of 2. Okay. Now, let's review some trig, enough algebra. So to review the unit circle, I have a blank unit circle here and I have a full one. Well, I have it divided out for you. You have a 0 degrees, pi over 6, pi over 4, pi over 3, pi over 2, and so on. You should know how to convert between radians and degrees and vice versa. I'm not gonna go over that. Okay, so now just to remind you how we did remember all this in trig, we would, this point is at 1 0, so it's easy to remember. So but just to show you the pattern, you start with the y value and then you go root 0 over 2, and then you increase by 1, root 1 over 2, you increase the y value by 1, so root 2 over 2, you keep the bottom, and 0 1 2, and then root 3 over 2, and then this one is going to be root 4 over 2, which is 1. And then you go backwards, same idea, root 0 over 2, which is 0, root 1 over 2, root 2 over 2, root 3 over 2, and root 4 over 2, which is 1. And that way you get the first quadrant, and then by symmetry, you get the second, the third, and the fourth. And there we go. There's the unit circle, a full one. Okay, so everybody should know the unit circle by heart. On the test, I will attach a blank unit circle. You may fill it out and use it for your convenience. Okay. All right, then inverse trig functions. Inverse trig functions. Again, this is a review, and I have a nice handout on D12 to review inverse trig functions. So let's review now the sine inverse. So f of x equals sine x. We know domain is negative pi over 2 to pi over 2, and range is negative 1 to 1. Why we do negative 1 to 1, although the range is all real numbers? Okay, because if you look at the sine curve, you can graph it in your calculator. Pi over 2, pi, negative pi over 2. So just to give you an idea, and this goes on forever. But if you only look between negative pi and pi, you can see it's not even 1 to 1. It doesn't pass the horizontal line test. And to have an inverse function, you need to have a 1 to 1 function. So we cut off everything from the right and left and only leave this interval from negative pi over 2 to pi over 2. So basically we get a function that looks like this. Okay, negative pi over 2 to pi over 2, 1. That's why the domain is negative pi over 2 to pi over 2 to have a 1 to 1 function. Otherwise it won't be 1 to 1 and we will not get an inverse function. Okay, so its inverse, if its inverse would be sine inverse of x, that's the notation we use, and domain, again they swap, x and y, and range is negative pi over 2 over 2. You can put this in your calculator to graph it. I have the graph on D2L, you can check that. And I'm gonna go over, so remember f inverse of f of x equals x. If, remember x has to be in the domain of sine, so x has to be between negative pi over 2 to pi over 2. Keep in mind, you can only use this cancellation rule in this interval. So when you're doing sine inverse, you're going to be either in the first or the fourth quadrant, right? First or fourth, because x is negative in the fourth quadrant. And sine of sine inverse of x is x if x is in the domain of sine inverse, which is negative 1 to 1. Okay, and then we have all these rules that you should look at. Y equals sine inverse of x if and only if sine y equals x. The I with the two f's means if and only if. It shows domain and range. Cosine inverse, tangent inverse, and so on. And then you have secant inverse, cosecant inverse. I wrote it all down, and it shows you when you can use cosine inverse, tangent inverse, and then I'm going to go over the examples. Keep in mind, this is very important, and I have that also in your notes on that chapter. When you're doing sine inverse, tangent inverse, or cosecant inverse, you're going to either be in the first or fourth quadrant, but fourth quadrant have to have negative values, negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, or these values. Okay, when you're doing cosecant inverse, cotangent inverse, or secant inverse, you're in the first or second quadrant. Because remember, one-to-one function, if you do cosine inverse of 1/2, it's going to give you one answer. So that's why you have to be careful, because it's a one-to-one function. Okay, so first or second quadrant for cosine inverse, cotangent inverse, secant inverse, and for sine inverse, tangent inverse, cosecant inverse, it's first or fourth, but keep in mind these are the fourth. Again, this is all in your D2L. So also, I put in D2L, it's a summary of trig, all the trig formulas, unit circle, and more trig formulas. Okay, so make sure you review that. So let's see some examples. So say I want to do number 70, page 66. How do we evaluate? Part A, tangent inverse of root 3. Well, to find tangent inverse of root 3, if we want, we can write it to equal x and then do tangent of both sides. So we can get rid of tangent inverse, since tangent is 1 to 1 when we restrict the domain. So tangent x is root 3. Since we're doing tangent inverse, remember, we can only be tangent inverse. We can only get a value between what? And either in the first or the fourth. And the first tangent is positive, and the fourth tangent is negative. Tangent is positive, so it's going to be in the first. And which angle has a tangent of root 3? You can check your unit circle. It's pi over 3. Any other answer would be wrong. Even your calculator is programmed to do that. So if you do tangent inverse of root 3, it gives you a decimal, but if you do pi over 3, then you will know that decimal is pi over 3. Okay? Although there's infinitely many angles whose tangent is root 3, but we're only looking for one because of the inverse. Part B, what's tangent inverse of negative 1? Again, let it equal x, so tangent inverse of negative 1 is tangent x. Tangent x is negative 1, so it's negative, it's in the fourth quadrant, it would be negative pi over 4. Okay, it's that angle, negative pi over 4. You cannot say 7 pi over 4. 7 pi over 4 is not between negative pi over 2 and pi over 2, so be careful. Okay, '72, page 66. 72, page 66. What is sine inverse of negative 1 over root 2? This equals x, and we sine both sides. So sine of x equals negative 1 over root 2. Again, since we're doing sine inverse, we're going to be between negative pi over 2 and pi over 2. It's negative, so it's in the fourth quadrant, which would be negative pi over 4. Okay, x equals negative pi over 4. Again, if you look at this circle, negative pi over 4 is right there. And if I want to do cosine inverse of root 3 over 2, then cosine x is root 3 over 2. Since we're doing cosine inverse, it's either first or second quadrant. Cosine is positive in the first. The angle that has a cosine of root 3 over 2 is pi over 6. Okay, pi over 6. Yep. Now, if you want to do 74, part A, what's sine inverse of sine of 5 pi over 4? Now, if we're doing sine inverse of sine of 5 pi over 4, like I showed you in the notes, sine inverse of sine of x equals x if we're in this quadrant, from in first or fourth quadrant, but we're not. 5 pi over 4 is in the second quadrant, so we cannot use the cancellation rule. We have to do it inside out. So we do sine of 5 pi over 4. If you look at the unit circle, sine of 5 pi over 4, 5 pi over 4 is negative root 2 over 2. And then we do sine inverse, and we let it equal x, and we already did that in 72. Okay, if you look at 72 part A, that was negative pi over 4. Okay, I'll just do one more. 78. What's sine of 2 cosine inverse x? Well, this is like sine of 2 u, where u equals cosine inverse x. Okay, so if u equals cosine inverse x, that means cosine u equals x. Now it says simplify. Okay, So cosine u is x, and we are in the first or second quadrant because we're doing cosine inverse between 0 and pi. Okay, so so cosine u is x. So if we want to do sine of 2u, it's 2 sine u cosine u, double angle formula. We have cosine u, then sine u would be square root of 1 minus x squared, because if you look, if this is u, if cosine u is x, cosine is this, so sine must be that. If this is a 1, because it's a unit circle, so this would be square root of 1 minus x squared using the Pythagorean theorem. Or if it's in this quadrant, same thing, okay? It would be positive. So sine of this would be 2 sine u, which is root 1 minus x squared, and cosine u is x, so 2x root 1 minus x squared. And that would be the answer. And that's it for this. I'm sorry if my computer went to sleep, so this is the work.